Okay, welcome to part 2 of this problem. So in the last video, we went over sort of all the statics that we need to know, and most importantly, a discussion on force couple systems. In this video, we are going to talk about the algorithm that we're going to use to solve this problem right here. So for the algorithm, the very first step is, well, let's figure out the inputs and the given. So in this problem, we are going to have a bunch of forces that are acting on this beam, and then distances from point A to each one of those forces. So the very first thing we need to do in our algorithm is create variables for those forces and distances. So in code, we're going to create a list right here, and that list is going to have every single one of those forces, and those forces are given, and I'll just assign it to some variable forces. And we can do the same thing for this variable called distance. I just shortened it to dist. And the distance variable is just going to be a list of those x values for each one of these forces. So you need to make sure that if this variable right here, this list has, let's say, 10 different forces, then this array needs to have 10 different locations, right? Each one of these array, the length of each one of these lists are going to be exactly the same. Okay, so that's easy enough. We define our input right here. The next step is to figure out the resultant force value. So if you remember from the problem, we need to figure out the value of this resultant force, and that is simply just the sum of all of these forces. So how do we figure out that sum? Well, I have two options here, and in this video, we are going to go with option 2 because it's much easier. But option 1 is essentially to iterate through this forces list and keep some sort of a tracking variable. So let's say you had a tracking variable called sum. What you would do is set this equal to 0, and then go one by one and add the value of this force to sum, and then go to the next element and add it to sum, and then continue doing that until you get to the last element. So we're essentially incrementing this sum variable until we've gotten through every single one of the forces in this array. Now that's a lot of work. There's a much easier way to do that, and that is using the sum method. And the sum method takes in 1 or 2 arguments. In this case, we are just going to pass in the list that we want summed, and it's going to spit out the sum of all of these variables. So I'll show you how to use that in the next video once we start writing code, but this is the option we're going to take. Now, after that, we need to find the equivalent moment at A. So in the last video, I explained that that was MA, the moment at A for this force couple system. And this one's going to be a little bit more involved. So remember, this diagram right here, we have a bunch of forces, and we need to find the moment of all of those forces at point A. Remember, the moment is just the sum of every single one of the force times distance calculations. So what we're going to do is we're going to start off with the first force. We're going to calculate its moment about A, and then add it to a tracker variable, and then add the next moment that's caused by F2, and then the next one, and then the next one, all the way until we get to the very last element. So in code, what that looks like is that firstly, we'll set up a tracking variable, and I'll just call that MAR, M-A-R. So that's just the moment at point A for that resultant force. And we're going to initialize it with a value of 0. So MAR starts off at 0. And then we're going to iterate through each one of the forces in this forces list. And then for each one of those forces, we're going to calculate the moment. Now, how do we do that? Well, we need, remember, the distance for each one of these forces is given in a different list. So what we need to do is we need to go through the first element, F, times distance x1, and then add it to that MAR variable, right? We're going to increment this variable. And then we're going to go to the next force, find its distance from A, calculate the moment, and then update this MAR variable. And then we're going to keep doing that until we get to the last element. And once we've iterated through all of those values, MAR is going to have that moment that we're looking for. So that moment, again, is this moment right here. Okay, so once we've iterated through every single one of those forces, then the calculation becomes fairly straightforward. So because now we know what MAR is, and we already have the value for R, all we need to do is take that equivalent moment divided by the resultant value, and that gives us X. So you might be saying, oh, where does this formula come from? Well, from the last video, remember that equivalent moment right here is effectively the same thing as that resultant force right here at some distance x from A. So that formula is R times X, which is this times this, is equal to this moment, which is that moment that we just calculated. And all I did in the algorithm was I just took MAR and I divided both sides by R, and that's how I got this formula. Okay, so simple enough. That's just one calculation after we figure out what MAR is. And then finally, we are going to print the results using a formatted string. So remember, in Python, we can create a string, print it to the console, but we can also inject values like the moment, the R value, and the X value. So that's essentially the algorithm. It's fairly simple, although this step right here is probably the most involved, and we just have to make sure we do it carefully. So that's it for the algorithm. I will see you guys in the final video where we're actually going to write some Python code. So see you then.